The most precisely built structure in the history of the human race was completed 4,500 years ago. Not the last century, not in the age of computers. 4,500 years ago. And we have never built anything that comes close to matching it. Its base, 230 meters on each side, is level to within 15 millimeters across the entire platform. Across 13 acres of desert bedrock, 15 millimeters. Its four sides differ from each other in length by less than 8 centimeters across 230 meters. It is oriented to true north, not magnetic north, true north, with an error of less than 1/15 of 1 degree. Its stone casing joints are so tight that the mean gap between them is 0.5 millimeters, half a millimeter, on stones weighing up to 15 tons each.
Modern engineers and architects, when confronted with these numbers, do not celebrate the ancient Egyptians. They go quiet, because they know what those numbers mean. They mean that by the most important measures of construction precision, a building completed before the wheel was widely used outperforms every skyscraper, every dam, every stadium, every structure we have raised since. In the next 10 minutes, we will go through those measurements one by one. And we are going to answer the question that no one in mainstream engineering wants to ask. How is that possible? Welcome to Lost Blueprint. Before we talk about precision, we need to talk about scale. Because precision at small scale is engineering. Precision at this scale is something else entirely. The Great Pyramid of Khufu, built around 2560 BC, originally stood 146.5 meters tall. That is taller than a 40-story building. At its peak, it held the record as the tallest man-made structure on Earth for 3,800 years. Not 300, 3,800 years. The base covers 13 acres. Put another way, the entire footprint of the Houses of Parliament in London fits inside the Great Pyramid's base with room to spare. So does Wembley Stadium. So does St. Peter's Basilica in Rome. It is built from approximately 2.3 million stone blocks. Most are limestone, each weighing between 2.5 and 15 tons. Some of the granite blocks inside the King's Chamber, brought from Aswan, 800 kilometers up the Nile, weigh up to 80 tons each. In total, the structure weighs approximately 5.75 million tons. 5.75 million tons of stone, placed block by block by a civilization working in the Bronze Age, using copper tools and human muscle. And every single one of those blocks had to be cut, transported, and placed with a precision that modern construction engineers describe, without exaggeration, as extraordinary. The question is not whether they built it. The question is how they built it this way. Let us start with the base. The platform on which the Great Pyramid sits was cut from natural desert bedrock. The builders leveled this platform across 13 acres, more than 53,000 square meters, to within 15 millimeters of perfectly flat. To put that that in context, modern construction tolerances for a high-quality building foundation specify levelness to within approximately 12 millimeters per 3 meters. The Egyptians achieved 15 millimeters across 230 meters. That is not just Bronze Age engineering. That is precision that would satisfy the requirements of a modern skyscraper foundation. They had no lasers, no GPS. Researchers believe they used a network of water-filled channels cut into the bedrock, essentially a giant natural spirit level. If that is true, it is one of the most elegant engineering solutions in history.
Now, the orientation. The Great Pyramid is aligned to true north, the actual geographic North Pole, not magnetic north, with an error of less than 4 minutes of arc. That is less than 1/15th of a single degree. This alone staggers surveyors who study it. Modern compasses cannot achieve this accuracy. They follow magnetic north, which deviates significantly from true north and shifts over time. The Egyptians, working without compasses, without GPS, without any electronic instrument, aligned a 5.75 million ton structure to true north more accurately than most modern instruments can measure. The leading theory today is that they tracked circumpolar stars, stars that circle the North Celestial Pole without setting, and bisected the arc of their movement with great precision. It is elegant, it is brilliant, and it would have required an astronomical knowledge that we are still only.
The 4 sides of the Great Pyramid each measure approximately 230 meters in length. The longest side and the shortest side differ by less than 8 centimeters. 8 centimeters across 230 meters is a margin of error of 0.035%. To visualize that, if you stretched a 230-meter tape measure across a football pitch, an error of 0.035% would be smaller than the width of a match. Now imagine achieving that, not with a tape measure, but with knotted ropes and wooden rods, coordinating thousands of workers across years of construction. And then there are the joints. The original casing stones of the Great Pyramid, the polished white limestone that once made it gleam in the Egyptian sun like a mirror, were fitted together with joints averaging just 0.5 millimeters wide. Half a millimeter on individual stones weighing up to 15 tons each. The Egyptologist Petrie, who surveyed the pyramid in the 1880s with extraordinary precision, described the casing stone joints as equal in quality to opticians' work. Not masons' work, opticians' work. The joints were not just tight, they were cemented with a mortar that, despite its extreme thinness, has held for 4,500 years. The chemical composition of that mortar is still not fully understood. Here is what makes all of this so remarkable, and so uncomfortable for the modern engineering world. We are not just talking about a structure that has survived. We are talking about a structure that was built to tolerances that challenge modern industry. And when you ask modern engineers, not television archaeologists, not YouTube theorists, but actual civil engineers and structural specialists, how the ancient Egyptians achieved this, the honest answer is always a version of the same thing. We are not completely sure. Not because we have not tried to figure it out, because the more carefully we study it, the more the numbers force us to admit that what was achieved here should not have been achievable with the tools we believe were available.
The tools we believe the ancient Egyptians used were copper chisels, wooden mallets, ropes made of papyrus and palm fiber, wooden sledges pulled across wetted sand, and dolerite stone balls used as grinding and hammering tools. Copper is a relatively soft metal. It cannot cut granite without enormous effort and constant resharpening. The blocks inside the king's chamber are red Aswan granite, one of the hardest stones on earth, and yet they are cut and fitted to millimeter precision. Some researchers have calculated that to cut, transport, and place one block every few minutes, around the clock, every day for 20 years, which is the rate required to complete the pyramid in that time frame, would require a level of logistical organization and engineering expertise that should not have existed in 2560. There are three mainstream theories. The first, external ramps of earth and debris spiraling up the pyramid as it rose. The problem, the volume of material required for such a ramp would have exceeded the volume of the pyramid itself. The second, an internal spiral ramp, proposed by French architect Jean-Pierre Houdin, which would have been constructed within the pyramid's core as it grew. This is elegant and increasingly well regarded by engineers, but it has never been proven. The third, that some of the blocks were not cut stone at all, but a form of ancient geopolymer concrete, essentially cast in place rather than quarried. Researcher Joseph Davidovovits has championed this theory for decades. It remains controversial, but it has never been disproven. None of these theories has been conclusively confirmed. The Great Pyramid has stood for 4,500 years. How it was built is still, in 2026, an open scientific question. To put the pyramid's precision in context, let us look at what we have achieved with modern engineering. Computers, GPS, laser leveling, and unlimited industrial resources. The Burj Khalifa in Dubai, the tallest building in the world at 828 meters, was built with an extraordinary precision that its engineers are rightfully proud of. Its vertical deviation from true plumb across its full height is approximately 300 millimeters, less than a foot across 828 meters, remarkable by any standard. The Great Pyramid's base is leveled to 15 millimeters across 230 meters. Scaling these tolerances proportionally, the pyramid is more precise relative to its footprint than the Burj Khalifa is relative to its height. As for orientation, no modern tall building is intentionally aligned to true north. There is no reason to be. City grids, urban planning, building codes, none of these require cardinal alignment. The Egyptians chose to align to true north, and then achieved it to within 1/15th of a degree without a single modern instrument. That was not necessity, that was mastery. The decision to align a building that precisely and then to actually achieve it represents an intentionality about precision that the modern construction industry simply does not share. In 2019, an expert team of engineers and archaeologists was asked directly, could we build the Great Pyramid today? The answer was, yes, we could build the structure. With modern cranes, GPS, laser leveling, and computer modeling, we could replicate the dimensions. But the project would take years, cost billions of dollars, and require logistical coordination that would challenge a modern army. what they could not guarantee was the precision. Because modern large-scale construction does not operate at sub-millimeter tolerances across 230-meter stone faces. That is not what we build toward. That is not what our industry is designed to achieve. We have more technology than the ancient Egyptians could have imagined. And we still cannot commit to building.
Here is what mainstream engineering analysis consistently misses about the Great Pyramid's precision. We keep asking how they achieved it with Bronze Age technology, but we are asking the wrong question. The more important question is, why did they care this much? Modern construction is precise because imprecision costs money. Poorly leveled foundations crack, misaligned structures fail. Precision is functional. But the Great Pyramid's precision goes well beyond what structural integrity requires. A pyramid 10 centimeters less level at its base would still have stood for 4,500 years. A pyramid oriented 5 degrees off true north would have been just as functional as a tomb. The precision was not functional. It was theological.
The ancient Egyptians believed the pharaoh, in death, would become one with the stars. Specifically, with Orion, the constellation they associated with Osiris, god of the afterlife. The pyramid's 4 shafts, extending from the king's and queen's chambers, are aligned with extraordinary precision to specific stars: Orion's belt, Thuban, and Alpha Draconis, the pole star of 2560 BC. The precision of the pyramid was not the goal. The precision was the proof. Proof that the structure was worthy of the cosmos it was pointing toward. Every millimeter of tolerance was a declaration that the thing being built was not merely a building. It was a cosmological statement, cut in stone, meant to last as long as the stars themselves. And in that sense, it has succeeded completely. 45 centuries later, it still stands. The Great Pyramid is the most famous example of ancient precision that modern engineering struggles to contextualize. But it is not the only one. Stonehenge in England aligns its main axis precisely to the midsummer sunrise and midwinter sunset, an astronomical calibration that would require years of careful observation to achieve. The Inca stonework at Sacsayhuaman in Peru fits massive polygonal blocks together so precisely that you cannot slide a piece of paper between them, just like the pyramid casing stones. And Angkor Wat in Cambodia was oriented to align with the spring equinox sunrise down its main causeway. Precision was not a Greek invention or a Roman achievement. It was a universal ancient obsession. Civilizations separated by thousands of miles and thousands of years all independently concluded that the most important structures must be aligned to the cosmos with perfect mathematical precision. We tend to think of precision as a modern capability, a product of technology, computers, and instruments. The ancient world shows us something different. Precision is a product of intention, of caring enough to get something right, of committing as a civilization to a standard of excellence that does not allow for good enough. The Great Pyramid is not just a monument to Khufu. It is a monument to what human beings can achieve when the goal is worthy of the effort. 4,500 years ago, in the desert outside what is now Cairo, a civilization decided to build something so precisely, so exactly, so astronomically aligned that the modern world is still not entirely sure how they did it. They leveled 13 acres of bedrock to within 15 millimeters. They aligned 500,000 tons of stone to true north within 1/15 of a degree. They cut joints in 15-ton stones to 0.5 mm tolerances, without GPS, without computers, without power tools. The Great Pyramid does not stand as a mystery because we lack the technology to understand it. It stands as a mystery because every time we look at it carefully, we are forced to confront the same uncomfortable truth.
If you watched episode 1 on Roman concrete, a material we have spent 60 years failing to recreate, you will see the pattern forming. The ancient world was not primitive. It was precise. It was intentional. And in many cases, it was operating at a level that we have not yet matched. Next week, we go inside Damascus steel, the legendary blade alloy whose carbon nanotube structure modern metallurgists openly admit they cannot replicate. It is one of the most astonishing stories in all of materials science, and we are just getting started. Subscribe so you do not miss it, and drop your single most surprising fact about the Great Pyramid in the comments below. I read every one.